What's up everyone, welcome back. Patrick here, and moving on to some more exponential practice. So we got to simplify these expressions starting with number 1. We got x to the negative 4, y to the 2 to the power of 3, and that's all over x to the 2, y to the negative 5. Now, first thing I'm going to do is I'm actually going to take these two negative exponents, I'm going to flip them to change them to positive. So the y to the negative 5 I'm going to bring up, that's going to become positive 5. These two I can multiply, so that would end up being y to the 6. And then I'll have x to the 2, and then the x to the negative 4 I bring down, that changes to x to the positive 4. Then from here, notice these two have the same base, so we could add the exponents since they're multiplying. Y to the 11, we could do the same thing here. We end up with x to the 6, and then notice that these are different bases here, so we can't simplify that any further. So that actually ends up being the answer to number 1. Number 2, it's a little bit more complex. We got x to the negative 4, y to the 2, all to the power of negative 1. Then that's all over x to the 3, y to the negative 2, that's all to the power 2. And then all of that is to the power of 4. So before dealing with this exponent 4, I'm going to try to simplify as much as I can inside the bracket. And a couple of ways we can go about this. So notice that this whole expression is to the power negative 1, so we can bring this whole expression down to the denominator. That's one way to do it. But because we have a fairly large expression here, what I'm going to do is I'm actually just going to take this exponent and distribute it, quote unquote, to these two terms, and then do the same thing over here because the terms are multiplying. Remember, if you got two terms that are multiplying all to an exponent, we could take each individual term to that exponent. And so this x to the negative 4 would go to the negative 1, the y to the 2 would go to the negative 1, and then the x to the 3 would go to the positive 2, and then y to the negative 2 would go to the positive 2 as well. Right, so this x to the negative 4 here, it's like this a, the y to the 2 is like the b, and then the negative 1 is the x, and then I just applied this rule over here, and then this is still all to the power of 4. Now at this point we can distribute the 4 if we want. I'm going to wait, as I mentioned, I'm first going to try to simplify this as much as possible, then I'll bring the 4 in. So here, notice we can multiply all these exponents. So negative 4 times negative 1 is positive 4, 2 times negative 1 is negative 2. Then over here we'll have 6, and then over here we'll have negative 4, like that. And then this is still all to the power of positive 4. And so from here, what we can do is I'm going to flip these. So I'm going to change it to be positive exponents, like that. So I just brought this up, brought this down, and now we have positive exponents on the y's. And then from here, what we can do is simplify the terms with the same base. So x to the 4 over x to the 6, so there's 4 x's at the top, there's 6 x's at the bottom, meaning that there would be 2 x's left at the bottom. These simplify. Another way is 4 minus 6, which is x to the negative 2, which is 1 over x squared. That x squared is in the denominator. And then over here we have 4 y's at the top and then 2 y's at the bottom, meaning we're left with 2 y's at the top once it simplifies out, or 4 minus 2. And then remember, this is still all to the power of 4. A fraction to the power of something means, I'm going to continue this here, the numerator goes to that power and then the denominator goes to that power. And so we'd end up with y to the 8 over x to the 8. And so that ends up being the final answer for number 2. And then number 3, I think it may actually be more simple than number 2. Here we got 4x y squared to the power of 2, so I'm going to leave that as is. However, this whole term is to the power of negative 2, so I'm going to bring that whole term down and change that to be positive 2, like that. And then from here, notice that we got terms multiplying. all to an exponent, so we could take each term to that exponent. So we'd have the x to the 2, then we have y to the 2 to the 2, and then we'd have 2 to the power 2, x to the 3 to the 2, and then we'd have y 2 to the 2, like that. And actually these two here are going to cancel out, I just noticed. But let's go in order. So we got, this would end up being 16, x to the 2, y to the 4, over 4, x to the 6, y to the 4. These cancel out, or they're the same base, so 4 minus 4 is 0, y to the 0 is just a 1. That's left over here. So those go away. 16 over 4 is 4, and then we have 6 x's at the bottom, 2 x's at the top, meaning that we're left with 4 x's at the bottom. Or 2 minus 6 is negative 4, x to the negative 4 is 1 over x to the 4. So that's in the denominator there. And then that ends up being the final answer for number 3.